Good morning, everybody. Thank you so much for sticking around for our talk. My name is Sriram, and I'm an architect at PayPal SRE. With me, I have Ashish, who is an engineer at PayPal SRE. We are building tools to protect, measure, and improve the reliability of PayPal products. Today, we are going to talk about a tool that we have built to measure the impacts from an incident. This talk is divided into 4 sections. We'll start with the basics of an incident, its life cycle, aftermath of an incident, and then the challenges involving in doing the assessment manually. Next, we will talk through the design of the tool, starting with the requirements of the tool, and then how the evolution of the architecture happened, and then architecture of the tool. Following that, we will talk through the mathematics involved behind the scenes. We started off with a very simple model of weekly averages, and then we advanced to using machine learning models. We will talk about how we started using machine learning model in our development. We will talk about the challenges that we have faced. We will talk about the various implementation considerations that we should take into account, and also on how to assess the machine learning models. Finally, we will talk through the features, major features of the tool, and then the opportunities that we have in front of us and the challenges that we have faced. Last but not least, we will also talk about, in case we have to build the tool for your use case, we will give some practical guidance on how to start about it. Okay, let's get into the basics. Right, before that, I just wanted to give you a quick recap on, here is a snapshot of our business. Here is a snapshot of our business in Q3 of 2022. We processed around 5.6 billion payment transactions, representing total payment volume of $337 billion through 432 million active consumer and merchant accounts. We connect people and businesses in over 200 markets around the world. This tremendous scale is powered by thousands of hardware and software components running across thousands of machines and are distributed across several availability zones. So we have availability zones that are there all across the world, and it runs both on-prem as well as on cloud. All these, our technological platform runs over 3,200 applications and services and multiple databases. We also support multiple programming languages. And all these components are monitored 24/7 through various observability systems, which raises alerts. Despite having a lot of preventive measures, we do get incidents in live. Right? Here is a quick recap of how the incident lifecycle happens. It's a very simplistic view. I hope that is the same case for most of us. Right? Once we determine that there is an incident on live, we either raise them manually from a portal, which will help us to automatically assess, prioritize, ask for a lot of information, or we can kick them in through a workflow automation as well. Once the incident is raised on a ticketing system, SRE prioritizes and classifies the incident using the prioritization matrix that we have developed exclusively for our use. Right? Once the incident is prioritized and classified, then we trigger the automated response plays, which will take care of creating the channels, inviting the people, and then does some communication as well. It also triggers automated troubleshooting, which will get a lot of information from a variety of systems, like what changes have gone in around the incident time, what are the other alerts that are probably coming up, and what are some of the critical alerts. Is there anything that we can tag this incident with another incident? So a lot of automated troubleshooting does happen, and in some cases, automated remediation do happen as well. With the additional information that we have gathered, SRE then does the manual troubleshooting in case if it is not enough from whatever the information that we have gathered, and then involve other teams as needed. Then we started doing the remediation, and then once the remediation is done, we verify that the system is restored back to normalcy, and then we finally resolve the incident. However, things are not done yet. The incident resolving is just to get back the site to normalcy. But there are a lot of things that happens after it. What is done after an incident is resolved? Here is a quick checklist of things that we probably that happens after the incident is resolved, but that is not very comprehensive. At a very high level, what we do is like we gather the incident timelines, when the start time of the incident, alert time, acknowledgement time, and so on and so forth. Next, we assess the impact from the incident. Typically, like what we concentrate on the transaction loss. When I say transaction loss, the TPV and the revenue from the incident, and then the availability loss, which means like how much percentage of our transaction didn't go through, or how much of our other capabilities were not available for our consumers and merchants. And then we also segment the data by various parameters, like by countries, by merchants, and so on. And then we also notify our customers, like both internal and external customers, various regulators, partners, and then we do update in our status page as well. Finally, we get to the root cause of the incident. We will go back and then see the sequence of events that happened just before the incident, and what has worked and what hasn't worked. And then once we identify the root cause of the incident, we will also look for any opportunities, especially like the lessons learned. We will look for it, and then we will also apply measures to prevent such incidents in the future. This talk is exclusively on the impact assessment, the item number 2 from the top. Okay, let us see, in case if we have to measure the impact of an incident manually, what are the challenges? One, it is very, very time consuming. In some cases, it can go for several hours as well. And then it is very much, it involves a lot of backbreaking toil, especially to segment the data by various parameters like countries and products, that too in the trenches. Not all will have the knowledge of the area, the domain, and there could be some challenges in interpreting the data as well. It is not very straightforward at times. Moreover, it is error prone. There is always an inherent urgency in assessing and moving forward. And as we all know, it is definitely not scalable as incidents happen simultaneously or as incidents keep occurring a lot. On the other hand, right, like we need instant assessment done for the following reasons. First, we need to report to our regulators, provided the incident matched the reporting criteria. The criteria could vary from regulators to regulators, and here are some of the regulators that we work with. This is not again comprehensive. These are some of the regulators that we report to, provided it matches the criteria. And there are some stringent timelines associated with reporting as well. It could vary anywhere between 4 to 72 hours. And our customers and merchants owe instant communication in case if there is an incident going on. And thus we also update in our site status page, PayPal status site page. So that is an incident going on. And in case if it is resolved, we will also update it. In general as well, like we need to know the loss incurred from the incident and segment it for the next steps. With that context, let's get into the design of the tool. Once we decided that we have to definitely automate this incident assessment calculation, the only high-level requirement that we know of at the beginning is that we need to automate the impact assessment process. That's all. The next step probably would be like how the impact assessment was done manually, so that we can see what steps were involved and we can automate accordingly. Before that, I just wanted to tell a simple and most important thing, right? Like one of the key things associated with, in general, any impact measurement is the metric that represents the core metric that represents the health of the business. When I say the health of the business, it could be anything and it could vary from business to business. For PayPal, it is the payment volume. Payment volume is a number of payments over a time window, say minute over minute, like what is the count of payments that PayPal is processing. On the right is a graph that is not an actual graph. In fact, like all the graphs that we are showing here are for representational purpose only, and it is not the actual graph. Now that we know the requirements and we know what the metric that we care about, let's get into the how the assessment is done manually, so that we can think of what parts we have to automate and what are the things that we need to take into account. So you are seeing two graphs, and both are almost same. These graphs represent the payment count by minute on a timeline fashion. On the left graph, we have taken an impact, which means there is a drop in payments between the two vertical lines in red. On the right, the area shaded under yellow is actually the impact. Typically, the way on a very, very simplistic way, we do the calculation using these steps. Step one is like, in fact, identifying the start time and end time of the incident, which is in many cases it is very obvious by looking at the graph. If not, there are other signals to tell that, like when does the incident start and when does the incident end. Once we identify the thing, then we have to pick a model so that like we can identify, had we not gotten the incident, what would have been the regular payments at that specific minute or at that specific moment. So we have to pick a model. Historically, we have been using X week average, which means like we go back to X weeks and then we see what was the payments at that point in time for the same hour and the same minute. So we go back X weeks back, we probably compute the mean of that and then use it as a reference. So this gives you a very good idea of what were the number of transactions that were flowing in about 2 weeks, 3 weeks, 4 weeks, and what we could expect. This involves a lot of approximation, but it works in most of the cases. So step two, we pick a simple model, probably like for this explanation, I would say like we can pick 6-week average model. And then what we do is like we calculate the modeled count for each minute within the window. When I say modeled count, like it is like taking average of the same minute for the previous 6 weeks, and then like we use it as the reference or the model count. And then impact for that specific minute is actually maximum between 0 and model payments less the actual payment. So we know like what is the actual impact for that specific minute. And then we calculate for all the minutes within the window, and then that is the total impact of the number of transactions that we have taken as a hit. And then revenue calculation is very much simple, which is a factor of the number of transactions that we have lost. Moving ahead, once we know the requirements and once we know how it is done manually, the next step is identification of the additional requirements. So what we need is like we need a system that can take in start and end time of the incident, and then probably that tool should probably talk to disparate real-time data sources to pick a lot of metrics, and then we need a way to visualize the metrics in a way so that like we can know what is the hit that we have taken. And then that could be scenarios where the model that we have been using may not be really aligning with the trend, so we may need to manually scale up or scale down the model count as needed. So this is not needed in all the cases. If the model is working perfectly fine, we do not need to do any more adjustments. But there could be scenarios where we may not see a very good trend of the metrics, so we may have to use it. So we may need to have that capability as well. And then finally, once the impact is assessed, we need a system to record the impact. With these additional requirements, like let's identify the key abstractions so that like we can build them in a tool. So we may have to have a front-end web-based user interface application that probably would authenticate the user, preferably using the SSO. So the user will see the landing page wherein the user will be probably choosing the start time and the end time. And then the tool should have an ability to talk to multiple, should be able to provide multiple models for consumption of the user. The user will be at liberty to choose any of the models that the tool supports. And then We would also need a very good charting library for data visualization, so that like the user is comfortable seeing the data and then will be very much happy that the impact calculated is correct. And then some other features to scale up and scale down, probably panning and other ways to visualize the data and use it effectively. Speaking of the patterns, we could solve this with a very simple n-tier or a multi-tier architecture, and a database may not be actually needed. And since once the impact assessment is done and it is persisted in one of the ticketing systems, people rarely go back and then rework on it. So we need to give a very good accurate view of what is the impact. So generally people will not go back and rework on that. So the database may not be actually needed. And speaking of the patterns that we can really use for talking to multiple data sources, we can consider facade data pattern, design pattern. And then for the technological choices, most of the popular technologies we can employ here, like whatever that the enterprise has been using, we can very well use that. With this, here is the architecture of the tool that we have built. So starting from the left, we have an user. The user will launch the browser and then probably type in go/impact assessment. So the browser will forward the request to the nearest traffic router, which is a URL path-based router. So once it identifies the keyword, like it will probably launch the application, which is the impact assessment web application. The application will load and then see that like the session is not established. So it will redirect for SSO, and then the user will be authenticated and the session will be established. Once the session is established, the user will be presented the landing page from where the user can start the can key in the start name and end the entire ticketing system. For that, like the web application would again forward it to the impact calculation server, which will persist in the ticketing system. Speaking of the components that we have to build, we just have to build two components. One, a web application. Another one is the mid-tier service called impact calculation server. The ones that are marked in blue are the ones that we have built. The ones that are marked in yellow were the things that were existing. With that, we can get into the core of the talk, which is all about mathematical modeling. I hand it over to Ashish to cover the mathematical modeling. Thank you.
Thank you, Sriram. Good morning, everyone. We'll continue from here on the context that Sriram has built around the tool and the requirements. So let's talk about the maths that go behind calculating the 6 weeks trimmed average, the first model that we tried upon. Okay, so Sriram has already defined a manual algorithm that goes through these 5 steps. The first one will be to identify the impact window, and for that particular impact window, we need to go through each of the minute, and for each of the minute, we need to go to the particular data source, which will be probably observatory system. We need to go there, we need to get the data from their APIs, and then probably use for a particular minute, if you imagine like if you're using a X week trimmed average where X is like 2 weeks, 4 weeks, or 6 weeks, then for a particular minute, you have like 6 weeks of data or 4 weeks of data. So you take these 4 weeks of data or 6 weeks of data, and what you do is that you try to remove the outliers out of it. A simple way to do that will be to find the maximum out of these values or the minimum out of these values, and to remove that away, because most of the outliers will be either the maximum value or the minimum value. So once we do that, we are left with the trimmed values. Now we take the mean of that, and we finally do some more manipulations on top of that to get the final model. A simple example is given. Suppose that some incident happened in the morning today. So suppose the first minute of that incident is 10:30. So at that particular minute, we observe the value of 4 for our business metric, that is TPV. And to find what was the expected TPV at that particular minute, what we did was that we went a week back, that is on the 30th November, what was the value at 10:30. Then we went back 1 week more, that is 23rd November. And what was the value at that particular point? It was 8. Likewise, we went until 6 weeks. that is until 26th October. And out of these 6 values, we see that the 8 is the maximum one, 3 is the minimum one. We remove these 2 values, and we are left with 4 values. We take the mean of that. That comes out to be 6. And we see that the expected value was more than the current observed value, that is 4. So if we take the difference, it's a positive value, that's 2, and that is the impact for that particular minute. So once we do this calculation for all the minutes within our impact window and we aggregate it, we get the final impact for that for our incident. Moving ahead, so finally, after doing this calculation through this algorithm, we will chart it out in a beautiful UI like this, where this green line is showing the 6-week trimmed average that we just calculated, and this yellow portion is part of that 6-week trimmed average, which is corrected for the current trend. Like when I say current trend, we see before the start of the incident window, which is marked by the start time in the red line. Before that, the current, like today's current value was trending a bit less than what we usually see. So we also need to correct the model to account for that trend that is happening today. So after that correction, we get that yellow line or the yellow area graph, and that is our model. So once we have that model, we can do some calculations, and we can have this table that is on the right that shows what is the payment loss percentage, what was the actual payments aggregated around within this impact window, and then what is the payment model payments, and likewise and finally we arrive at net payment loss. There is one more term, recapture. We'll talk about it in the next slide. Okay, so it happens during the incident that most of our users will be waiting for our systems to come up back live. SREs will go and they will try to restore the systems, and after some minutes the systems will be restored. And all of a sudden the payments will start to go through the systems. So at that time, what will happen is that most of these people who are waiting in the queues and retrying again and again, most of these transactions will be able to recapture because we acted fastly, and likewise. So these we will see that restored payments as a sharp spike in our payments trend. This spike is compared to the norm or the model that we calculated. So what we do is that out of the impact that we calculated, we discount this recaptured payment, the recaptured transactions, and we finally arrive at the net payment loss. Oh, so that is recapture, and in some cases what happens is that once we calculate the scaled model that we talked in the previous slide, it still doesn't align very well with the current trend, and user may be dissatisfied with the model that we have offered. So in those scenarios, like in the current picture in the middle one, we see this yellow line to be not very well aligned with the current trend that is going on before the start of the window. If it would have been a little bit higher, maybe it would have been aligned better. So we give this ability to the user. What they can do is that they can pull up or down the slider, which is there in blue, onto the right of that chart, and they can scale the model up and down. So on the right side, we show the same model scaled by 5% towards up. So these are some of the additional functionalities that we have built in the tool. And here is the final math. Without not going much into the detail, I'll go through them briefly. So the first equation that is there on the top, it shows that you give the start time and the end time, and you can have the impact. And the second line, we calculate the recapture. On the third line, we calculate the net impact from the impact and the recapture that we just calculated. On the remaining 4 lines, what we are doing is we are trying to remove the outliers for a particular minute, and we are trying to get the expected value for that particular minute. Finally, we need to scale it to align with the current trend. For that, we pad the impact window for some minutes in the beginning and in the end, and we see what is the norm for that padded window. And in this case, we take the median. And what we do is that we compare the model with the preceding data, and we get the norm of that particular comparison, that is median, and we use that as a factor to scale. And finally, we arrive at the scaled expected series, the second last equation, and finally with that we can calculate the revenue loss. So that concludes the 6-week trimmed average model that is being used for most of our systems. And apart from this, what we did was that there are many machine learning algorithms out there for time series forecast. And like in our research, we saw that like there are more than 180 models out there. So we tried some of them like ARIMA and its variants, Light GBM, LSTM, and NBEATS. And to try out these models, we had to go through the similar machine learning life cycles. Like we had to gather the data, we had to analyze them first, we have to pre-process them first, and then we tried multiple models. We had to compare them against each other, we have to test and validate them, and finally we had to deploy them into the production. And a lot of this was done using the cloud platforms that are there with the enterprise. But before jumping into the machine learning models, there are some challenges that one should think of. The first one was that like a 6-week trimmed average is very fast. It's basically a mean, and you can calculate it in a very fast way. But some of the machine learning models, they take a lot of time to predict. So we should be careful. Like our machine learning models should predict their values in near real time, as our use cases like that. The next is many of these machine learning models require some constants to be met, like seasonalities and trends. So a lot of pre-processing and analysis has to be done. The third thing is some of the machine learning models need more data than the others, and sufficient data needs to be there. And then a comparison has to be done out of these many models which are available there. And finally, how to conjugate this model with the existing system that we have, that has to be considered. Given these considerations, we first tried ARIMA. So ARIMA and its variants, they work pretty fast in some cases, but and they have various parameters. So the one that worked best for us was ARIMA 302. But we had some challenges with it, like we were not able to very well productionize it because of the challenges with the training that we had. And we compared it to the 2 weeks averages model and the 6 weeks averages model that we had, and we found that it was working in par with those. The next model that we tried was actually, it was a collection of models that we tried using the platform S2O. So S2O is a driverless AI platform through which what it does is that it tries multiple machine learning models and it recommends what is the best working for the data set or the task that we have. So what we found was that the Light GBM model was working best for us in most of the cases. The mean absolute percentage error for the model was around 5 to 6%. And then the next step for this process was to compare it against the current model that we had, that was 6 weeks average model. And the final conclusion that we had after the comparison was that the 6 weeks average model was more practical and is still very efficient compared to the machine learning models that we had. For the Light GBM 1, our conclusion was that we did not have sufficient data. Like most of the machine learning models, you need to have a large corpus of data to train. So with that, let's look into the other features that we have in the tool and the takeaways, like how we can extend this to any business. We have defined some other matrices around which we calculate impacts. One is through FCI and availabilities. For availability, within the tool, we show the first chart for the availability impact. There, we compare the availability that is observed during the incident against the static baseline that we usually have. And below that, on the left side, we show the count of FCIs that we have during the incident, and on the right side, we show the number of CIs that we have during the incident. In many, and finally, the aggregate of the FCIs, that is failed customer interactions that happen within the impact window, we aggregate them and we call it as a FCI impact. And in many cases, when we see a sharp decline in the CI chart, not in this case, but in many cases we'll see a sharp decline in the CI chart, we can consider them as FCI impact as well, and we can have that included in the FCI impact. Next, a logical next step for us was to further divide this impact assessment in various dimensions like country, product, business matrices, and merchants. Some of these were required to fulfill the compliance regulations that we meet, and some were required for a better insight into the businesses that we have. And one challenge that we faced through this journey was like when we tried machine learning models, it's become very hard to train the new models on the limited data that we get after segmentation. We also employed this framework, which is very generic in nature, to other business units that we have within PayPal. And a general flow looks like this. The first one is that for a particular business unit, we have to find what is the key business metric, like what it may be transfers, it may be the number of payments that's happening. And then we have to understand what is the life cycle or various tools that they are using for the current impact assessment framework that they have. And then we have to identify from where we can get their observability data. And once we have identified that, we need to find the right APIs and we need to integrate with them. And then we need to validate whether our generic models that we have developed are working against their data or not. And some opportunities or the challenges that we are trying to solve as of now is like giving the users ability to try out different models and then finally observing which model the user is using and using that feedback to again improve the models. And other important aspect is that we are trying to automate the complete experience from end to end. That is, like when the incident happens, it goes through the restoration process. And once that is done, the tool should be kicked on automatically. It should calculate the impact and it should report it without any human intervention. An important aspect of that will be identifying the incident window itself, apart from other characteristics like recaptures. And finally, expanding it to other business units that we have within PayPal, like Venmo. Some of the algorithms that we have tried on the automation fronts are like to find, like we try our best to find the right multipliers to scale the model to align with the current trend. But in many cases, the confidence of that scaling is low. So in those cases, we can semi-automate it by taking the feedback from the user, or like if we have low confidence, we can ask the user whether they want to accept the scaling or not. So that is one effort that we are doing. The other thing is that how we, like it is a time series identification problem where we want to see like where the recapture ended, so that the users don't have to put the recapture time manually. And it is very evident and obvious in some cases, but in other cases, when the time series is very noisy, it's very difficult even for humans. And finally, to automatically identify if there is a drop in the CI chart and to include that in the FCI impact. And a few challenges that we have on the tool as of now is that it heavily relies on the users. And it is very hard to test as we grow into various dimensions and business units. Modeling is again a challenge. Building intelligence to completely automate it, as I have already highlighted, like in many cases, it's very hard for humans as well to identify whether there was a recapture or whether there was an incident or not. So automating that itself is a very challenging task. And finally, a lot of approximations are there in the building of this whole framework. And the final takeaway is like how a new business can adopt this framework. So the first step in that journey will be to identify what is the key business metric for them. And to, like for a mobility company, it may be the number of rides they book per minute or per 5 minutes. And for an ad company, maybe it may be the number of viewers who are there on the platform at a particular minute. And then they need to see like in which dimensions they are interested in, like products, countries, as per their compliance requirements and interest. The second thing will be to make sure that their data sources are capable enough for integration and provide real-time access or delayed access to the data. The third thing will be to assess their existing manual assessment workflow and to see whether anything needs to be improved upon that, and then finally automate it. And to automate it, they will need a model, and that itself is a long journey that starts with identifying the key characteristics of their own data and going through the modeling lifecycle that we discussed. And finally, it will require remodeling from time to time with the additional data that comes in. And because this is impact assessment framework, this will need to integrate with various already existing impact assessment, already existing SRE frameworks that we have. With that, we have came to the end of this talk. Please let us know if you have any questions.